In the grand tapestry of the cosmos, where stars are born and galaxies dance to the silent music of gravity, there emerged a mind that would come to read the notes of nature's symphony. This is the story of Albert Einstein, the architect of relativity, whose ideas illuminated the shadows of our understanding and unveiled the fabric of space-time. Our tale unfolds in the early 1900s, in the bustling streets of Bern, Switzerland, far removed from the hallowed halls of academia, where one might expect revolutionary ideas to spark. Here, in a humble patent office, a young clerk with an unassuming demeanor and a shock of untamed hair sat hunched over stacks of technical documents, his mind adrift in a sea of thought. Amidst the toil of patents and the tick of the office clock, Einstein's imagination soared beyond the confines of the tangible, into realms where time slowed and space curved. He pondered deeply on the mysteries that the luminaries of physics had left unsolved, and he grappled with the enigma of light, that constant celestial messenger whose speed seemed an immutable barrier. With a daring only matched by his profound insight, Einstein embarked on a series of thought experiments, the likes of which no one had dared to conceive. He envisioned himself racing alongside a beam of light, peering into its wavefront, and in these mental voyages, he glimpsed the outlines of a universe governed by a new set of rules. His pen, guided by intuition and an unwavering trust in the simplicity of nature's laws, began to etch onto paper the framework of his theories. The special theory of relativity shook the notions of absolute time and space, uniting them into a single continuum that could stretch and compress, while the general theory reimagined gravity, not as a force, but as the bending of the fabric of space-time itself. Einstein was not merely a physicist, he was a philosopher of space and time. Through his insights, we were granted the lens to view the universe anew, a realm where time is relative, space is fluid, and mass and energy are interchangeable. His theories invite us to step through the looking glass of relativity, into a universe more strange and beautiful than we could have ever imagined. As the 19th century gave way to the 20th, our understanding of the physical world was rooted in the clockwork precision of Isaac Newton's laws that had stood unchallenged for more than 200 years. Factories hummed with the rhythm of the Industrial Revolution, and scientific progress seemed as orderly as the tick-tock of the ever-present pocket watch. But beneath the surface of this mechanical certainty, a storm was brewing. Electromagnetism had thrown a wrench into the gears of classical physics. Light, that elusive wave of energy, refused to conform to the established rules. Its speed, a constant, not dictated by the motion of its source, hinted at a deeper truth waiting to be uncovered. In a Swiss patent office, a young Albert Einstein, with his wild hair already hinting at the rebel thinker he was, pondered the mysteries of the cosmos. The patent office was a crossroads of innovation, a place where the practical met the theoretical, and for Einstein, a perfect crucible for genius to thrive. Einstein imagined riding alongside a beam of light, a thought experiment that would be the spark for a revolutionary idea. If he traveled at the speed of light, what would he see? Would the light appear as a static wave frozen in time? This was the paradox that set him on the path to relativity. Amidst the ticking clocks and the steady glow of electric lamps, Einstein saw a universe that was far from the predictable machine of Newtonian mechanics. It was a universe where time and space were intertwined, a fabric that could bend, twist, and ripple in response to the mass and energy it contained. It was a universe waiting for its moment of revelation, and in 1905, that moment arrived. In a world bound by the steady pace of time and the unyielding dimensions of space, Einstein was about to unravel a tapestry woven by Newton himself. A tapestry that, until now, had depicted a universe absolute in structure, unmoving in its essence. With a stroke of genius that would mark his miracle year, Einstein penned the special theory of relativity, a theory that rested on two astonishing postulates that challenged the very nature of reality. The first postulate declared that the laws of physics are the same for all observers in uniform motion, whether they're gliding along a frictionless ice surface or hurtling through the cosmos in a spaceship. No experiment, no matter how clever, could distinguish between these steady, unaccelerated voyages. The second, and perhaps more startling postulate, stated that the speed of light in a vacuum is absolute. No matter how fast you chase a beam of light, it recedes at the same unwavering speed. This universal speed limit governs the cosmos, indifferent to how fast or in what direction you might travel. From these bold postulates, a cascade of consequences tumbled forth, each more mind-bending than the last. Time dilation, a concept as mesmerizing as any conjured by the most imaginative science fiction, revealed that time itself could stretch and compress. A clock moving relative to you ticks more slowly, so that a traveler, moving swiftly enough, could return to find themselves younger than their stay-at-home twin. Length contraction paints a universe in motion, where space itself is malleable. Objects contract along the direction of travel as they approach light speed, becoming squashed as if viewed through a cosmic lens. And at the heart of this dance of space and time lies the most famous equation in physics. E equals mc squared. Mass and energy, the substance of matter and the vibrancy of motion, are but two sides of the same coin. A startling alchemy that powers the stars and forges the destiny of the universe. As these revelations spread through the scientific community, the foundations of physics trembled. A new worldview was taking shape, a vista of reality where the fabric of space-time was no longer rigid and absolute, but fluid and relative to the observer's motion. In the tale of gravity, Newton's apple had long ago hit the ground, but its journey was far from over. Einstein, gazing through the eyes of curiosity, saw not an apple falling, but space itself reaching up to meet it. It was here, in the curvature of space-time, that the general theory of relativity began to take shape. Einstein's genius whispered to him of a principle so profound that it would become the cornerstone of his general theory, the principle of equivalence. It stated with elegant simplicity that the effects of gravity and acceleration are indistinguishable. To the occupants of a closed space like an elevator, the pull of the Earth and the push of acceleration felt exactly the same. With this principle as his compass, Einstein ventured into the uncharted territory of the cosmos. He envisioned a universe where space-time was not flat, but curved by the mass and energy of celestial bodies. Planets and stars were not pulled by invisible forces, but followed the natural contours of space-time, like marbles rolling along a curved surface. From the warping of this cosmic fabric emerged predictions so bold they seemed like the musings of a madman. Light itself, Einstein asserted, would bend around massive objects, tracing the curvature of space-time. Clocks in strong gravitational fields would tick more slowly than those far from such influence, their rhythm set by the gravity's embrace. The universe, ever the arbiter of truth, did not keep us waiting long for evidence. The solar eclipse of 1919 provided a stage for one of physics' most dramatic moments. Stars near the sun, visible in the darkened sky, appeared slightly out of place, their light bending just as Einstein had foretold. Today, the fingerprints of general relativity are found in the technology that powers our GPS systems, in the cosmic ballet of binary pulsars, and in the swirling maelstroms of black holes, where space-time succumbs to the pull of infinity. Einstein's vision of gravity was no longer a force acting at a distance, but the very stage upon which the drama of the universe unfolds. His general theory of relativity had transformed our understanding of the cosmos, not as a static arena, but as a dynamic, ever-changing masterpiece. In the cosmic sea, Einstein's relativity was not merely a ripple, it was a tidal wave, reshaping the shorelines of science and philosophy. The reality once perceived as immutable was now a mosaic of relativistic effects, each piece more intriguing than the last. From the depths of space, the theory summoned forth black holes, regions of space-time so dense that not even light could escape their grasp. These celestial enigmas were once mere theoretical curiosities, but today they stand as monuments to relativity, their event horizons acting as the ultimate proving grounds for Einstein's legacy. Relativity reaches into the fabric of our daily lives, guiding satellites that sail the sea of space, their onboard clocks ticking to the rhythm of both special and general relativity. Without these relativistic adjustments, our GPS devices would drift into confusion, leading travelers astray. In the subatomic coliseums of particle accelerators, relativity plays out in high-energy collisions. Particles energized to velocities nearing light's own bear mass that swells according to relativity's dictates, a spectacle of energy and momentum choreographed by Einstein's principles. But the echoes of relativity resound beyond the confines of science. They permeate philosophy, challenging the very notion of time and existence. Einstein's universe, a tapestry where the threads of time and space intertwine, invites us to ponder our place in this vast and wondrous cosmos. In the realms of art and culture, relativity has ignited imaginations and inspired visions of reality, where time travel and parallel universes are not just possible, but plausible. It has become a staple of science fiction, a touchstone for storytellers and philosophers alike, grappling with the nature of time, existence, and the universe. Einstein's legacy is written in the stars, etched in the pathways of particles, and woven into the very fabric of our understanding. Relativity is not just a theory, but a testament to human curiosity, a beacon that continues to lead us through the uncharted waters of reality, and a reminder that our quest for understanding is as boundless as the universe itself. As we gaze into the night sky, we are not just spectators, but participants in a cosmic dance that spans the vastness of space and the depths of time. Thanks to Einstein, we see the universe not just as it is, but as it can be, ever dynamic, ever relative, ever awe-inspiring. As our odyssey alongside Einstein comes to its horizon, we pause to gaze back at the trail we've traversed, a path lit by the stars of inquiry and paved with the stones of perseverance. We have journeyed through a universe reimagined, where time and space are the canvas and mass and energy the brushstrokes of existence. Relativity, once a maverick idea sprung from the fertile grounds of a single mind, has rippled across the century, permeating science, philosophy, and the collective consciousness of our civilization. It has redefined the fundamental notions of space and time, mass and energy, gravity and light. In the legacy of relativity, we find the blueprint for the technologies that bind our world, the theories that guide the questing spirit of science, and the inspiration for the stories that fuel our dreams. Einstein's gift to humanity extends beyond equations and experiments. It is the empowerment to question the very nature of reality. And as we stand on the shoulders of this giant, our eyes set upon the stars, it is our wonder, our insatiable thirst for knowledge, that propels us forward. The future beckons with promises of revelations as profound as those of Einstein, waiting for the next curious soul to unravel them. The story of relativity is not just Einstein's, it is ours. It is a testament to human ingenuity, a chronicle of overcoming the once impossible, a narrative of expanding our horizons beyond the visible, beyond the known. It is a reminder that in the fabric of the cosmos, we are but threads woven into the vastness, yet through our understanding, we become weavers of destiny. In the symphony of the cosmos, with its celestial bodies moving in silent harmony, relativity is the music of the spheres, an eternal hymn to the beauty of the universe and the ingenuity of the human spirit. As this chapter of our cosmic journey concludes, we carry forward the torch of knowledge, a beacon passed from Einstein to us, and from us to the generations to come. And so, under the canopy of the cosmos, We continue to contemplate, to explore, to dream. For in the quest to understand relativity, we do not just discover the universe, we discover ourselves, timelessly reflected in the endless dance of light and gravity.